Hey, what's up, guys? This is Jung here again. So today, let's take a look at LeetCode problem number 306, additive number. It's a media level problem, but it's kind of tricky. Okay, so an additive number is a string whose digits can form additive sequence. And a valid additive sequence should contain at least three numbers, and except for the first two numbers, each subsequent, starting from the third numbers, each of the numbers should be the sum of the preceding two numbers. And given a string containing only digits 0 to 9, write a function to determine if a given string is an additive string or not. And note that the number cannot have a leading 0, so which means 0, 3 and 0, 0, 2 will be invalid. So what does this mean? For example, we have 1, 1, 1, 1, 2, 3, 5, and 6. Right, so the entire string is an additive number. So why is that? Because 1 plus 1 is equal to 2. So 1 plus 1 equals to 2. And then what? And for each number, right? Remember, so for each number, not, which means that, starting from the third numbers here, right? So 2 is equal to 1 and 1. And 3 equals to 1 plus 2. 5 is 2 plus 3. And 8 is 3 plus 5. So this one is obviously an additive string here, but this is just only the simplest case because each number only has one digit. And example 2 is a more complicated case. So in example 2 here we have 1 9 9 1 0 0 1 9 9. So the additive sequence number is actually this is 199 and 100 and 199, because with these four numbers, right? So 1 plus 99 equals to 100, and then 99 plus 100 equals to 199. That's why these four numbers will make an additive sequence here. But as you guys can see, so the difficulty for this problem is that we don't know how many digits a number can have, right? Because for this one, if you choose 1 and 9 for the first two numbers, right? If you choose 1 and 9, and then the next one is what? It's like 9 1 something, right? And this one will not make an additive sequence. That's why this one will not work. So how can we solve this problem, right? And so we're solving this problem is just by using what you can call it like backtracking or DFS. Basically, what we do is that we try all the possible combinations for the first two numbers, right? Try all the possible combinations for the first two numbers, and then we'll try to verify if the first two numbers plus the remaining numbers can fit can form an additive sequence. If we can't, if none of the combinations can form additive numbers, we simply return false. As long as there's one combination that can form an additive sequence, then we return true. So what does this mean? It means that like this. So for example, right, we try all the possible, for example, let's say we try the first number, the number one is 1, right? And number two is what is 99. Assuming we're at this state right now. And then the number 3 is what? So number 3 is always everything that's after the number 2. In this case, it's going to be 1 0 0 1 9 and 9, right? And we're going to have like a DFS function here. So we have three numbers here, number 1, number 2, and number 3. So this DFS is simply to check, given this number 1, number 2, and number 3, can these three numbers form like an additive sequence? So how can we know if these three numbers can form an additive sequence? there are like two major cases. So the first case is what? If number one, right? Number one plus number two is equal to number three. If right, if that's the case, of course this one will be a true, right? So this is the first case. And how about the second case? The second case, you know, of course, the answer will be this one plus this one does not equal to number three, right? But does this mean it will be false? Not necessarily, because this is like the second case scenario here, you know. So 1 plus 99 equals 100. As you guys can see, as long as this target, let's say this target is a prefix of the number three, then it means that okay, so we can up to this 100, right? It could still be an additive number. So we know that we know the up to this 100 is an additive number. So we just need to check if the remaining part, if plus the remaining part is still an additive number. But okay, so that's and but if this 100 is not even a prefix, then we're sure that this thing is not cannot form an additive number. We can simply return false. But so this one is the tricky case here. So with 199 and this 100 is a prefix of the number 3, how can we continue, right? So the way we're continuing is that, we're just calling this the same DFS, but instead of number 1, number 2, and number 3, we have to shift that numbers to the right, which means that, we have DFS. Now as you guys can see, now we're checking if this 199 it can still form like additive number, which means that now the number 1 becomes to 99, and number 2 becomes to 100, and then the remaining parts is whatever remaining parts becomes to number 3. So as if like, once we have find the answers here, right? Part of the answers here, we're shifting this number 1, number 2, and number 3 to the right by some position. And then we continue doing that until we have find a true answer, right? So in this case, like I said, the number 1 will become to number 2. And how about the number 2 in this case? The number 2 is like this. It's a number 1 plus number 2. In this case, it's 100, right? And then the number 3 is what? Number 3 is whatever the previously number 3, subtract, remove the 100 parts, which will be the remaining parts, the remaining of num3. Yep. So that's basically the main idea for this recursive DFS, Okay, cool. So with that, let's start. We can start coding. So, but here, as you guys can see here, so we have follow-up here, right? So how would you handle overflow for very large input integers? As you guys can see, even though the number length is only within the 35, but I think the follow-up is saying something like, what if this length is pretty big, which means if we're doing like number one plus num1 plus num3 num2 here, if we do an integer uh, add, it could be got overflow if the string is long enough. So the way we're handling it is like, at least for me, I just, instead of using an integer plus an integer, I use a string plus string. So basically, I'm not comparing the 100 to 100 with integer. I'm comparing the 100 string with the 100 string. So the string will not be overflow. Okay, that's how I handle it. All right. So with those being said, I think we can start coding it. Mm, So where should we start? And so the first thing first is we need like the n, right? N will be the length of the nums. So the first step, right? Find all num1 and num2 combinations. Okay. So how can we find it? So the way I'm finding it is basically I just loop through all this entire string from what? From I in range of n. So this is how I find it. Assuming we have this string here, so I just looping through from 0 to I here. So it means that the I up to I is my two string here. Mm, and I will just use a different j in between here, different j to cut this I into num1 and num2, and whatever after I will be num3. That's how I iterate all the combinations. Okay, so it means that now we have a j in range I. Okay, I mean we could start from one here, or here we also start from one, but it won't affect our final result because with the empty string it won't find a match. Yeah, so that's why I have num1 equals to what? Num1 is the from the starting point to the j, right? Which will be num j plus 1. Okay, so that's the first one. And then we have a num2 equals to what? Num j plus 1 to I plus 1, right? And then we have num3 is what? Is whatever after the I plus 1. Actually, we can do a little bit in pruning here. For example, if the num1 plus if the biggest, if the longest num1 or num2 is even longer than num3, then obviously we will never get an answer, right? But it will not improve the total time complexity, and I would just leave it here. I will not change this for loop range here. I will leave leave it to the DFS to return false for us. Okay. So and if the DFS num1, num2, and num3, right, is returns true, then we know, okay, we have true. Else, if none of them can form an additive sequence, in the end we return false. So now it's time for us to implement this DFS, right? So to implement DFS, we have num1, num2, and num3. Okay. So and first we need to handle the leading zero case for all of those three numbers here. So which means that if the length, we can either check it either here or in the DFS. Doesn't really matter. I just choose to check it inside the DFS here. So if the length of nums 1 is greater than 1, right? Because if it's just one numbers, I think 0 should still be counted as a valid number, right? That's why we only check if the length is greater than 0 and, right, and the num1 0 is 0, okay? Or, right, that's for number 1, I'll just copy and paste for num2 and num3. So I'm checking all three numbers. If any of them is true, I return false. It means that it's not a valid case, right? So now we have a target sum, right? So we have target sum. Sum is what? I'm assuming we have like helper functions, like I said, to do a string sum given num1 and num2. So this target sum is also a string. Okay, so now it's the base case, right? Basically, if the target sum is the same as the num3 string, then we know, okay, we find a, a a base case which is true. So that's this is the base case where we have find a final answer, right? Where then we need to return true. Otherwise, if this one is not true, we have to check two things. First, we check if the length of the num3 is equal or smaller than the okay than the I'll just do n here. N is equal to the length of the target sum, right? So we have target sum here. Yeah. So why I'm using a length of target sum because target sum could be bigger than both num1 and num2 because we might have like a +1 digits, right? And if the current number, right, is equal or smaller than the n, it means that there's no way this num3 could form like an additive sequence because here we already check if we already know that number 3 is not does not equal to target sum. And if it's even smaller or even the same length, then we know we can simply return false, right? Now here we have what? We have like now num3 is longer than the target sum. So we check one thing. We check if the target is the prefix of num3, right? If num3 if target sum equal to the num3 if it's a prefix. So the length of the prefix is n. If this is the prefix, then okay, we can continue, right? Continue DFS, and now the num1 will become to num2, and the num2 is become to the target sum, right? And then the last one is whatever left for num3, which will be anything that's starting from n, right? So that's that. Else we return false, right? Because if the current target is not even a prefix, we can safely return false because we know this will not form an additive sequence. Cool. So that's that. All right. So this is the main DFS. Now let's implement the sum2 here. Uh, okay, I'll just quickly implement that sum2. So this part is pretty standard, right? Basically, we have answer equal to 0, right? And then we have p1 pointer 1 is length of the num1, right? -1, right? Because we want to do the plus from the end to the start, okay? And then we have a +1 equal to 0, okay? This will help us to record the carryover, right? So first we have p1 is equal or greater than 0, and p2 equal or greater than 0, right? And then we have what? We have plus. We'll do a div mod, right? So for the we have int. We have to convert since we need to do a div mod. We have to convert the int of num1 to p1, right? This is the p1, the number 1 plus int of num2 p2, right? And then we always do a +1, right? And then we do a div mod by 10. And then the first one is our new plus one, right? And the second one is the current value, right? Equals to that. So we have to answer dot append the current values, right? And then we do what? We P1 minus 1, P2 minus 1. Okay. So now we have calculated all the common parts for num1 and num2. Now we have to calculate whatever is left. This one is actually similar like merging two sorted lists, right? We use two pointer techniques here. So while P1 is greater than 0, I'll just copy it here, So now if there's still something left for number 1, I'll just use this one. So at this time, because we don't have we don't need a P2 here. That's why we can only have like P1, num1 plus this one, and then we have P1. Same thing for P2, right? I'll just copy and paste here. For the case that P2 has something left, I'll just do this. So now we have num2 and P2. We have P2 here, okay? And in the end, right, don't forget, if there's still something in the plus one here, we still need to append one at the beginning to the end. And then we return what? We return a string, but we have to reverse the answer, okay? Because we are like traversing from the end, and when but we're adding the answers from the beginning. That's why in the end we have to reverse this answer and then convert it back to a string. Yep, I think that's it. Okay, let me try to run the code here. Oh, okay, we have a invalid syntax here. If this one and okay, so we are missing like a equal sign here. All right, nums. Oh, line 50. There's no nums. I think there's only num. Yeah. Okay. Dot join answers dot. So what sequence number exact string since int find. Oh, sorry here. Since we're concatenating a string side, we have to convert this integer back to the string. I know this conversion part is a little bit annoying, but that's the way it is. Okay, so we have to convert this one to a string. Otherwise, it will complain. Okay, run. All right, so accepted, submit. Oh, string index. Line 57, string index. Oh, sorry, here. I'm missing a colon here, which means that I'm not getting this I plus, I'm getting whatever left, right? So submit. Cool. All right, so it's accepted. Yeah, how about time complexity, right? I mean, here we have a n square here for the nested for loop here, and then we have a DFS. So the DFS is like an n here because every time we'll be moving forward by the worst case is by 1 all the time. I mean, this sum2 might increase the time complexity, but I'm not counting it in here because this one is just to handle the follow-up. So without this one here, I mean, the time complexity will be close to n square n cube here. We have a n square plus n here. That's why we have a n cube. Cool. Yeah, I think that's it. I mean, just to recap, right? I mean, this is like not the traditional backtracking or the DFS, with the traditional, like the normal DFS or backtrackings, we usually have like what? We usually have like a DFS, we have a starting index, right? We have an index here, and then from the index, we'll have some current numbers, right? Something like that. And then from the starting index, we'll loop through from the starting index to the end, and then we'll update the current index, and then we'll continue so on and so forth, right? But this one is like there's like a rolling the recursive, which means we if we find a match, if we find a match, we will have to move this our index, I mean partially, right? Partially we have to switch the variables, right? From num1 to num2, from num2 to the target, and then from the remaining parts. We cannot simply just bypass to the num3 here, because the reason being is because for the remaining parts, we need the previously two numbers to check that, to be able to find out if that remaining part is still can still form like a additive sequence. That's why we have to do a switching here, right? Or a rolling DFS recursive call here. Cool. Yeah, I think other than that, I mean, just it's just like this special handling, right, for the string comparison. Yep, cool. I'll stop here. Thank you guys for watching this video, and stay tuned. See you guys soon. Bye bye.